Hello everyone, this is your course instructor Harshita. So now in this session we'll be studying about table lookup decoding using the standard array. So in this type of decoding, first we'll form a table which consists of various code words, and then with the help of this table we will detect the errors in the code word, and we'll also correct that particular error with the help of this table. So now let's say we have an n comma k linear block code, okay, which is denoted by a capital letter C. And let's say that this code vector is used for correcting purposes. Okay, so what we'll be correcting here is basically obviously it's the errors. And next, let's say that we know that we can generate code words from the linear code n comma k, right? So let's say that the code words are c1, c2, c3 till c2 to the power of k. For example, let us consider a 6 comma 3 linear code. So in 6 comma 3 linear code, we have solved an example and we found that we obtained 8 code words. So when the value of k is equal to 3, we will be getting 2 to the power of 3 number of code words. So here when it is 3, 2 to the power of 3 will be 8. So C1, C2, C3, C4, C5 and up to C8 will be getting. So that's how we should analyze the number of code words that we'll be getting from a given linear code. Okay, and let R be the received vector. So now here the decoder will perform the task of associating this received vector with any one of the valid code vectors that is present. So now we'll just consider an example in order to understand this concept. So let's consider an example wherein the parity matrix of a 6 comma 3 linear code is given, and it is 1 0 1 0 1 1 1 1 0. Okay, so if linear code is 6 comma 3, what should we analyze first is the values of n and k. So from this I can write the value of n is 6 and the value of k as 3, and the parity matrix is given. So now we should obtain the code words. So how will we obtain the code words? Since the value of k is 3, we will be getting 2 to the power of 3 code vectors, that is nothing but 8. So now the code vectors is given by the product of message vector with the generator matrix. So now message vector will consider it as to be d1, d2 and d3. Okay, since k is 3, message vector will be d1, d2 and d3. So now next we should write the generator matrix. The generator matrix, first before starting off we should remember these 4 formulas. That is, generator matrix is given by identity matrix followed by parity matrix. Identity matrix should be of the order k here. And next H matrix, that is parity check matrix, is given by transpose of parity matrix followed by identity matrix of order n minus k. And next the code vector is given by message vector into generator matrix. Next syndrome S is given by received vector into parity check matrix transpose, that is HT. Okay, so next let's get back to this problem. So G is given by, that is the generator matrix is given by IK followed by parity matrix. Since the value of K is 3 over here, we can write I3 followed by parity matrix. So first I'll write identity matrix of order 3 as such, and then I'll write the given parity matrix over here. So this is the generator matrix which I got. And now in order to generate the various code vectors, I'll write C is equal to D1, D2, D3 multiplied by the generator matrix which I got over here. So now after multiplication, I'll just multiply D1, D2 and D3 with all the 6 columns that is present in this generator matrix. So I'll write code vector as D1, D2, D3, D1 plus D3, D2 plus D3 and D1 plus D2. So this is a code vector that I got. So now I'll form a tabular column and then I'll write the code names as CA, CB, CC, CD and so on till CH. Okay, I'll be getting 8 code vectors out of this. So since k is equal to 3, the message vector will be of 3 bits. So I'll write 000, 001, 010 up to 111. Okay, if you remember, we have solved based on this. We have solved a problem based on this topic also. So now after writing this message vectors, these are the values of D1, D2 and D3. So now with the help of this code vector, I'll write for D1, D2 and D3. First I'll substitute 0, 0, 0. So I'll be getting the code vector as 0, 0, 0, 0, 0, 0. And next similarly I'll substitute 0, 0, 1 for D1, D2 and D3 and then I'll get the code word as 0, 0, 1, 1, 1 and 0. We've solved a problem wherein we are generating the code vectors for a given linear block. If you have any doubts, you can get back to me or else you can go through that lecture video. Okay, so after generating this code words, what do we do is we will form a tabular column. We'll form a tabular column in which the first column consists of syndromes. So how will we find the syndromes? The syndrome is calculated as S is equal to product of received vector into H transpose. Okay, product of received vector, that is R, into the transpose of the parity check matrix. So how do we find this syndrome? So first for that we need to find the H matrix. So how do we find this H matrix? Transpose of parity matrix followed by identity matrix of order n minus k. Here n is equal to 6 and k is equal to 3. So 6 minus 3 will be 3. So first I will be writing the transpose of parity matrix followed by identity matrix of order 3. So this will yield the H matrix. So now after taking the transpose of this matrix, I will be getting a 6 cross 3 matrix. So that is written over here. Okay, so that is written over here. So you will be getting 101, 011, 110, 100 and 010 and 001. So this is the 6 cross 3 matrix that you will be getting when you find the H transpose matrix. So this part of this problem is given for you to do. Okay, so I want you all to determine the H transpose matrix and check whether you'll be getting these set of values. Okay, so now in this method, table lookup decoding using the standard array, as I mentioned earlier, we will have to form a table. So in that first column will be the syndrome, and before writing what is this syndrome is the entries in the H transpose matrix or the rows in the H transpose matrix, we call it as syndrome. Before writing that first row, we should always write 0, 0, 0. In first row of syndrome, we should always write 0, 0, 0. And next, in this first row, we should write the code vectors that we got over here. The code vectors, 8 code vectors that we got over here should be written in the first row against this 000 syndrome. Okay. So you can see that the code vectors are written over here. And next, this first column is always called as coset leader. Coset leader, because it will have less number of ones. And then the succeeding columns are called just cosets. Alright. So coset leader, how will we are supposed to fill all the code words here now. Okay. So how will we fill? So here you have 101. So this is the first entry in this syndrome column, isn't it? So here, these are the code words that we have written over here. So this is the actual data or the correct data. Next here, the corrupted data or the data which has error will be present. So since this is the first entry, there will be error in the first bit. You can see the first correct data or the non-corrupted data, we have all zeros. So here 101, this is the first row. In first bit, the error should be there. So this is the first bit. So if it is 0, I'll write it as 1 and all the other elements are zeros. And next here also, this first bit I have 0. So I should change it to 1 in order to introduce an error. So I'll change it to 1 and rest all the bits are written as it is. And here also we'll be changing the first bit from 0 to 1. Here also we are changing from 0 to 1. Here we have 1 in the first place. So we'll write 0. Okay, here also the same. Here also, and in the last column also. And next, coming to the third row. This is the second entry in the H transpose matrix, second value or the second component. So what we'll do here is we will introduce an error in the second bit. Okay, take the correct data as the reference. Okay, always we should be taking the correct data as the reference. Okay, so here we have 0000000. So in the second bit I have to introduce an error. So since second bit is 0, I'll write 1 and I'll write the rest of the bits as it is. And next here also second bit is 0, I'll change it to 1. Here the second bit is 1, I'll be changing it to 0. Here second bit is 1, I'll be changing it to 0. Here second bit is 0, I'll be changing it to 1. Here second bit is 0, I'll be changing it to 1. And here both the cases, second bit is 1, I'll be changing it to 0. Next 110. This is the third entry in the H transpose matrix or the third component. So what I do is, keeping this correct data as a reference, I'll be introducing an error in the third bit. So here in the third bit we have 0, we'll be writing it as 1 and rest all the other bits I've written as it is. And next here also in the third bit we have 1. In the while writing the code word, we'll change that 1 to 0 in order to introduce an error. So likewise, we'll change all the bits from 0 to 1 or 1 to 0 if it is in the third position, because this syndrome is in the third entity. Next, in fourth entity, we'll change the fourth bit from 0 to 1 or 1 to 0 in order to introduce an error. So this is the fifth entity, 010. So now what we do is, see, if you can observe here, fifth bit is 0 in this correct data. Okay, so I'll write that 0 as 1 in order to introduce an error. Next here we have 1 in the fifth bit, so I'll write 0 here. Okay, so likewise we'll be changing all the bits, the fifth bits from 0 to 1 or 1 to 0 while writing these set of code words. Next, this is the sixth entity in this H transpose matrix. So in the sixth bit position, I should be introducing an error. So how will I do that? If 0 or 1 is present in the sixth bit, that particular bit will be changed to 1 and 0 respectively. So like this, we will change the bits in the respective position and introduce an errors. So now how will we identify the errors and correct the errors? So for that, let's consider an example. Okay, so let's consider that the received vector is 1 0 0 1 0 0. Okay, so the syndrome is given by S is equal to R into H transpose. Okay, this R is given over here as 1 0 0 and 1 0 0. Okay, so that I'll write it here, and then H transpose matrix is that we have found out. Okay, so write that over here. Now, so now multiply all these values with the first column values and we'll be getting 0. Multiply all these values with the second column values, we'll be getting 0 again. Multiply all these values with the third column values, we'll be getting 1. So we got syndrome as 0 0 1. So this is a 1 cross 6 matrix and this is a 6 cross 3 matrix. So we should be getting 1 cross 3 matrix, which we have got it as 0 0 1. And all of you please observe this 0 0 1 is the sixth entity in this H transpose matrix, isn't it? So all of you please observe here this 1 0 0 1 0 0. Please check for this value in this tabular column and you'll find that 1 0 0 1 0 0 is over here. Okay, here we got syndrome as 0 0 1. So in this syndrome 0 0 1 over is 0 0 1 is over here, and here I'll search for this received vector 1 0 0 and 1 0 0. So that I have it here. So this is the code vector that has error. So what is the correct code vector? Correct code vector will always be present in the first row of the respective column. Okay, so the correct code vector is 0 0 0 1 0 1. Instead of sending this data, due to the error present in the channel or the external environment, the data received over here is 1 0 0 1 0 0. So how will we correct that? Here 0 0 1 is in the sixth position, right? So the error vector will be basically 0 if the correct data is passed. If there is an error, here we'll identify that there is error in the sixth bit. So in the sixth bit, we'll be changing that 0 to 1. So we'll get 0 0 0 0 0 1 as the error vector. Okay, so the corrected code vector is given by C is equal to R plus E. So the received vector is 1 0 0 1 0 0. So I'll write that over here. And the error vector is 0 0 0 0 0 1. And the corrected code vector will be the addition of these two code vectors, that is received vector and the error vector. So we'll be getting 1 0 0 1 0 1. So this is the way in which we will identify whether the value obtained in the tabular column is matching with the value that we have found out by performing an addition of received vector and the error vector. This is just another way to cross check whether we have the method followed by us is right or not. So here also the correct code vector is 1 0 0 1 0 1. Here also we got the correct code vector as 1 0 0 1 0 1. So this is how we detect the errors and correct the errors that is present in the code vector. So now I want you all to consider the received vector as 0 0 0 0 1 1 and then find the syndrome and identify the error and also find the corrected code vector. So this is the solution for that. I want all of you to solve this. In case of any errors, I'll clarify your doubts. Thank you. This is it for this session. We'll continue with the next topic in the next session. Thank you once again.